In this problem, we want to synthesize this ketone from the alkyne. And we know that by hydration of alkynes followed by tautomerization, we can get a ketone. But if we think about our carbons, our alkyne here only has 2 carbons, whereas our ketone has 3. So let's say these 2 carbons come from the alkyne, we somehow have to add this other carbon. Well, we can do that through an alkylation of the alkyne with the acetylide ion. So let's use our acetylene, which we know is relatively acidic. I'm going to treat this with a base. One option is NaNH2. Another option, which is pretty common, is butyl lithium. And that's actually a butyl chain with a lithium, but if you break that apart, lithium plus, carbon minus, which is just a strong base. And then we want to add 1 carbon, so let's just use iodomethane. So step 1, we deprotonate that to get the acetylide ion. So we get C minus. And then I'll just rewrite this step 2, bringing the CH3I up here. Then this does a substitution. The negative attacks this carbon, displaces the leaving group, so nucleophilic attack. Now we have our 3 carbons. In this first step, when you use this butyl minus to grab the proton, if you want to write it, the byproduct there is just butane. Okay, so from now, what we want to do here is a hydration and effectively add H and OH across the triple bond. Since we have a terminal alkyne, we need slightly harsher conditions, so we need the mercury 2 catalyzed hydration. So we use mercuric sulfate, sulfuric acid, and water. What this is going to effectively do, without going through all the mechanism steps, we're going to add H and OH across this triple bond in a Markovnikov fashion. The H will go to the terminal side where there's more hydrogen. The OH will go to the more substituted side. And we go from the triple bond to the double bond. There's our OH. We have our original hydrogen and our new hydrogen. Then this enol will undergo tautomerization to give us the ketone. So this carbon becomes a CH3. The carbon with the alcohol becomes a C double bond O. And if we write this as more of a bond line structure, we have our target.